In a multi-agent system, the objective is to funnel disparate work streams into a single central hub, allowing one person to handle the output of an entire department without adding layers of human management. To manage this volume, the Realm framework uses the Codex, a shared, centralized database that serves as the operating memory of the entire company. In practice, the human player and multiple specialized AI agents continuously read from and write to this record, updating information and executing tasks asynchronously. This constant activity creates a specific risk. When multiple autonomous actors operate within the same environment, the possibility of overwriting the current state or corrupting the shared record is constant. In typical shared environments, data degrades quickly. Agents delete historical context, versions fall out of sync, or conflicting entries paralyze logic. A standard company wiki relies on human discipline to stay organized, but that model fails in a dynamic environment where machines process and output data at speeds humans cannot manually monitor. Scaling these hybrid systems requires more than just capable agents. It requires a method for keeping that shared record from diverging as different actors make changes at the same time. This represents state drift, when a system's recorded configuration no longer matches its actual running state. In a human agent workflow, this happens when actual business data diverges from the codex. This divergence fractures reality. Agents might execute tasks based on outdated, overridden, or contradicted inputs. Often, this is caused by a human operator manually fixing a final calculation or top-line metric to reflect a new assumption, without updating the underlying raw data that produced it. That manual intervention breaks the closed logic loops agents rely on. When the end result disconnects from the source data, the agents lose the mathematical continuity required to operate autonomously. To address this, the Realm framework uses a protocol called Codex Reconciliation, a system designed to detect and resolve these discrepancies automatically. If the system cannot resolve these conflicts as they occur, the data becomes unusable for autonomous work, causing the hybrid system to stall. To prevent corruption, the Realm framework partitions all data in the codex into two categories: writable fields and derived fields. Writable fields are the root inputs of the system, the primary source of information. These are the only areas within the codex where human players or data-gathering agents can directly inject new information or make manual updates. Raw transaction logs, strategic direction files, and meeting notes all function as writable fields. Derived fields are outputs calculated exclusively from that underlying writable data. These fields belong strictly to designated AI classes. Human operators are barred from editing them directly because the agent owns the calculation. These fields create a mathematical cascade. An agent's derived output becomes the writable context for the next agent in the sequence. By segmenting memory this way, the system creates operational boundaries that prevent agents and humans from overriding the logic that drives the business. We can see this in action within the finance zone, where the separation of fields maintains the accuracy of the company's bottom line. This is the profile of a mage, the agent class responsible for intelligence and analytics. Here, the mage is the authority on financial state. The daily flow of transaction data, every individual sale and cost, is recorded in the codex as a writable field. The total revenue calculation sits on top of those transactions as a derived field. The mage is the sole owner of the total revenue field. The human operator provides the transaction data, but the agent determines the final number. Isolating this calculation ensures the macro metrics used for strategy are always a direct reflection of the microdata found in the transaction logs. The system is tested when a human player decides to bypass this rule, manually editing the total revenue field to reflect a more optimistic projection. This override severs the link between the top-line number and the actual transaction data, creating a false state within the codex. If left uncorrected, the risks cascade. Marketing agents might increase ad spend based on a surplus that doesn't exist, and inventory agents may overorder products the company cannot afford. To prevent this, the mage acts as a state controller, comparing the human's declared state against the actual state derived from raw data. Sweeping the codex, it verifies the total matches the mathematical sum. Upon finding a mismatch, it detects system drift. The mage immediately flags the discrepancy in the codex and blocks any subsequent agent actions that would rely on that corrupted revenue figure. By assigning this monitoring role to an agent, the framework ensures the system remains anchored in reality, regardless of human error. Following the detection, the reconciliation protocol reverts the derived field. The manual edit is wiped away and replaced by the correct mathematical calculation based on the raw logs. To change that revenue number, the human is redirected to the corrected workflow. They must update the raw transaction data and allow the mage agent to process the new total. This forces the operator to address the underlying assumptions. If you want a different outcome in the codex, you must change the facts that produce it. This reinforces the primary rule of the architecture. Derived fields cannot be manually overridden. This constraint is what builds trust between the human and the agents. If the agents can rely on the data as fact, they can operate with the certainty required for autonomous execution. In this framework, a manual override is not an executive decision. It is a system drift that must be corrected to maintain the integrity of the whole. When this logic is applied across every zone of a company, the impact on a solopreneur's ability to scale is significant. Fragile automation often breaks when humans interfere with the sequence. This self-healing architecture allows the company to expand without the data structure becoming a bottleneck. Using agents as state controllers reduces the time a human spends on database management and administrative error checking to near zero. This allows a single human player to orchestrate dozens of specialized characters with the confidence that the shared record remains accurate. Autonomy in these hybrid organizations relies on an incorruptible data architecture. When the shared record is mechanically protected from drift, agents can act with the certainty required to move the company forward.